right, so as you just saw, synthetic division is a really fast way to divide a polynomial by a binomial. Okay, so there's limitations to this. You can actually divide by a trinomial, but it's much harder and it's much more complicated, and you might as well just do long division at that point. Okay, so but it is possible. So you want to use this. Use when dividing by a binomial. And the other thing that you have to pay attention to is if the binomial you're dividing by, if the leading coefficient is not 1, you have to make it be 1 by dividing every term by that same number. So let's throw that in there. I'll do an example in a bit. So if the leading coefficient of that binomial is not 1, then you must divide every term. So divisor and dividend. By that number. So you basically force it to be 1 if it's not. And then you can proceed like normal. Okay? So here's your steps. So how to. Step 1. So you're going to put everything in standard form. And I'm going to put a star here and say remember, let's spell it right. Remember to put in 0 placeholders for any missing degrees. So same thing that was going on with long division. If I'm starting with x to the third and I don't have an x squared, I have to put in a 0 placeholder for it. Otherwise, none of my numbers are going to make sense and it's going to be totally wrong. Okay? So just make sure that they're all in, everything's in standard form. And it would be helpful to do an example out at the same time. So let's, I'm going to do number 6 on the same sheet that you have. So let me see if I can zoom out and I'll just recopy number 6 here. So number 6 you were doing, hi. That's not you. Oh, here's yours. There you go. Okay, so you've got n to the third plus 13n squared plus 31n plus 19. And we are going to divide that by n plus 10. Okay, so step 1, I make sure that everybody's in standard form. They are. Do I need any 0 placeholders? No. I have to the third, second, first, and then a constant. It's all fine. Everything's fine. The leading coefficient of my binomial is 1, so I don't have to worry about it. So everything's fine. Step 1 is fine. So step 2. You are going to copy down just the coefficients of your dividend. So write down coefficients only of the dividend. So that's the thing getting divided. So I just copy down all of your coefficients. Make sure you're watching the signs too. These all happen to be positive. But if any of them were negative, I would make sure to copy it down as a negative. Okay, so there's that. And then I draw this L shape. Everybody does this a little bit different, but I just kind of draw that. I don't know. You do what you want. It just sort of separates what I'm plugging in, what I'm not. And now, the number that I'm going to plug in, remember, I want the solution from that factor. So in other words, it's always the opposite of that number right there. So in this case, it would be -10. So that's step 3. So you're going to plug in the 0 from the factor, from the binomial. Let's say that. AKA the opposite of the number you see. If it's 2n plus 10, then you have a problem back in number 1, and you'd have to divide every single thing by 2. Okay, so in our case, it's going to be a -10, so I'm going to sneak in a -10 right there. All right. Step 3 is just bring down the first number. Yeah, just kidding around. It's not like I teach math or anything. Bring down first number. Whatever it is. So that one just comes straight down. I don't do anything to it. And now I start this process of multiplying the number on the front by the number at the bottom. And I put my answer in the next spot here. So I multiply and write down the answer. So step 5, multiply number in front, let's say on left maybe. Maybe that's better. Number on left by number on bottom. Put answer in next column. Am I going too fast? Just tell me if I am. So back up at my example, I'm just going to do -10 times 1, and I put my answer in the next column. And now I'm just going to add these two numbers together. So there's step 6. Add the two numbers in that column. And then you're basically going to repeat steps 5 and 6 until there's no more numbers. So I'll just say on step 7, repeat 5 and 6 until done. So when I add these two numbers, 13 and a -10 leaves me with a 3. And now I'm just going to repeat 5 and 6 again. So I'll do now -10 times 3, which is, and that goes in the next column. So I write -30 there. Now I'm going to add these together. Yeah, and it's really fast once you do them. I mean, obviously this one's taking us a long time, but they get really fast. So I've got a 1, and then I just do it one more time. -10 times 1 is -10. Add, I get a +9. So now, there's nothing left for me to do. I just have these 4 random numbers at the bottom here. Well, they're not really random numbers. They always go in this pattern. The very last number is always your remainder. So sometimes it'll be 0. And if the remainder is 0, that just means that it divided it evenly, right? So the very last number is always the remainder. And then you work your way up. That number is always the constant. Then we go x to the first power, x to the second power. If there's more numbers, you just keep going up the line until you're out of numbers. But you always start at the end. So this number is the remainder. Oops, let's spell remainder right. Jeez Louise today. Remainder. This number is always your constant. This number is my x to the first coefficient, or let's say, well, it's your linear term constant. So let's say linear term coefficient. So it goes in front of the x. This would be your quadratic term coefficient, if you want to be fancy about it. So in other words, that's going to go in front of x squared. And if you have more numbers, you keep going up the line. So you're never going to leave your answer like this. If you write 1319 on your paper, I'm going to be like, what the heck is that? I don't know. But now you know to turn that into, okay, that's the remainder. So it's going to be 9 over whatever you divide by. And then these are the coefficients. So I have 1x squared plus 3x plus 1, and then my remainder is a 9, so it goes 9 over whatever I was dividing by, which was, oh, these are all supposed to be n's. Sorry. Ugh. Sorry. I didn't realize our variable was an n. And there you have it. Okay, let's try another one. Let's try 8. So 8, you have a to the third minus 10a squared plus 28a minus 51. And we're going to divide that whole thing by a minus 7. So, is it in standard form? Do I need any zero placeholders? If you think you have a good handle on it, go for it. See if you can turn that into a final answer using this cool new method. If you're still a little shaky on it, I'll kind of walk you through it again. So I'm going to take all my coefficients, 1, negative 10, 28, negative 51. Make sure you keep the signs of each one. Then, yeah, sure. Then I'm going to draw that little L shape to sort of separate my numbers. And what's the number that you're going to plug in here? Positive 7, right. So it's always the opposite of that number. Oh, and I should have checked that my leading coefficient was 1, but it is, so I don't have to worry about it. So I'm going to plug in a 7. And then remember, the first number just always comes right down. And then it's just this pattern of multiplying, putting the answer here. Add those numbers together, and then you just keep repeating. So 7 times negative 3 is negative 21. Add them together, that's a 7. 7 times 7, 49. Add them together, negative 2. So now I have these seemingly random numbers at the bottom, but I remember, oh yeah, they're just the remainder and then the coefficients of each term. So the right way to write my final answer would be x squared minus 3x plus 7 minus 2 over, they're a's, gosh, sorry, I always do that, over a minus 7. And that's it. You should get the same exact answer whether you do long division or synthetic. It doesn't matter. Okay? I know you might be thinking, why would I ever go back to long division? This is so convenient. Remember, what if you're trying to divide by a trinomial? You're going to have to do long division. Sometimes, if I tried to do number 13 using this new method, it would have actually been really annoying. Because if you look at 13 real quick, look at what you're dividing by. So first of all, I'd write it as 7n plus 9. But a is not 1, so I'd have to divide everybody by 7. Not all of these are divisible by 7. And I'd be plugging in negative 9 sevenths. You want to deal with that? I don't want to deal with that. So in a case like this, I'd be like, you know what? I'm just going to do long division. Because it wasn't that bad doing long division. Here, it'd be a ton of fraction action. And I just want to avoid it. Sometimes it's not so bad if everything is like, okay, 14, we'll do 14 with synthetic. Here's a time when a is not 1. But if I quickly glance, okay, a is 2. If I divide everybody by 2, they're all even, so this is going to be great. This will turn out just fine. So let's go ahead and do 14 together, and that'll be one good example when A is not 1. Oh, did everybody get this? Did you all get the same answer? Yeah? All right, cool. So let's try 14 together and see how we do. Okay, so I'm just going to recopy it. 2b to the 4th minus 6b to the 3rd plus 4b minus 4. And I'm going to divide that whole thing by 2b minus 6. Okay, great. There's actually two things going on here. Oh, this is a great example. What else is happening here? I need a 0 placeholder because there's no b to the 2nd power. Okay, so I need that. So it actually doesn't really matter which one you do first. Because whatever, I don't know. Alright, let's plug in that 0 placeholder. So I'll just have a plus 0b squared plus 4b minus 4. Okay, and then because A is not 1 here, you have to divide everybody by 2. So both of those numbers get divided by 2. So I'm not dividing by 2b minus 6 anymore. I'm going to be dividing by b minus 3. And all of these terms have to get divided by 2. Every single one. Whatever A is, you have to divide everybody by it. So now I have b to the 4th minus 3b to the 3rd. That stays a 0. 2b minus 2. And I'm going to divide that by b minus 3. Does that make sense? Is that okay? So everybody gets divided by whatever that leading coefficient is, and I had a 0 placeholder, so I need to put it in. Now I'm going to proceed like I normally do, because now A is 1, I'm in standard form, I'm good to go. 1, negative 3, 0, 2, negative 2. And we will plug in a what? Positive 3. And we'll just go through our motions. It's okay if I get some zeros down here. It's not a big deal. Okay, did you get what I got? So far, so good? So now I need to unpack this. Okay, here's some random numbers. I got to turn them into some meaningful answer. The last number is always the remainder. Constant, x to the 1st, x squared, and now I do have an x to the 3rd term. In my answer, I don't need to include the zeros. I don't have them. So my final answer, if I write it all nice and neat, would be x to the 3rd. Don't have an x squared, don't have an x to the 1st, plus 2, and then my remainder of 4. 4 over, and now here's what I actually don't know. I don't know if it's by the, I think it's b minus 3 now, and not the 2b minus 6. I'm actually not 100% sure. I'm going to ask at lunch. I think it's over the new one after you divide. I'll find out. All right. So, what do we think about synthetic division? It's pretty awesome, isn't it? Saves us a ton of time. So, there is something else that I want to show you after lunch, but if you want to get started, I'm probably going to have you do, I don't know, odds on the back. So those are all synthetic division ones. So if you want to see how many you can get through before lunch, that's not a terrible idea.